Hi everyone. Welcome to this climate seminar dedicated to climate change adaptation and mitigation. It's our fifth episode so far in our fourth seminar series. For those of you who don't know me, I'm Charmilino and I'm project manager at Climate. I'm going to be the moderator of today's session. As you can see on the screen, here is the agenda of today's session. First, we're going to start with Edouard Davin. He's going to present his talk, Nature-Based Solutions for Climate Change Mitigation and Adaptation. Then Peter Bebi will present Management, Climate Adaptation and Climate Mitigation in Mountain Forests for the Alps. The session should end around 1:15. As you can see, both titles are in English, meaning that the two presentations will be in English. But don't hesitate if you have questions in French. I'm going to be happy to translate them. You can write your questions in the chat as we go, or we can simply open your mic, open your camera when the time comes for the Q&As and discuss with our two great speakers. So first, I'm going to introduce Edouard Davin briefly before his presentation. Professor Edouard Davin is a climate scientist studying the interactions between the terrestrial biosphere, land use, and climate. His work aims to demonstrate the key role of land use and land management in the transformation towards sustainable futures. He served as the lead author in the Intergovernmental Panel on Climate Change Special Report, Climate Change and Land. His professorship at the Wyss Academy is affiliated with the Climate and Environment Physics Division and the Oshger Center for Climate Change Research at the University of Bern. So, Edouard, the floor is yours.
Yes, so good morning or good afternoon to everyone. Thanks a lot for this introduction. So yes, I'm going to focus on or to talk about nature-based solutions or approaches from a climate perspective, looking at whether this type of approaches can provide benefits in terms of mitigation and adaptation to climate change. And I will look at it from the perspective of the research we are doing within our, sorry, the slides are going a bit too fast, research that we are doing in our group at the Wyss Academy. So that's the group on climate scenarios for sustainable development. And basically we have 3 research pillars that will also structure the presentation. The first one is about assessing impacts and risk. So that's the problem side, basically. The second pillar is about designing these nature-based approaches that can address this risk. So really looking at the solution. And indeed, we do focus on the nature-based part of the solution to climate change. It doesn't mean that there are non-nature-based solutions that should be implemented. Of course, it's complementary with, for instance, technological solutions. But we have this focus in our group to look a bit more into these nature-based approaches. And the third pillar is about upscaling these responses to larger scale and assessing the trade-offs and synergies. So what happens if we do apply these nature-based approaches at a larger scale? So this will be the structure of the talk. And I'm going to first illustrate the first pillar, so give 2 examples of what we do in terms of assessing risk. The first one here is about basically biodiversity projections. So we project biodiversity in the future, looking at species that are mammals, birds, and amphibians with species distribution modeling. And we also, in addition to this species distribution modeling approach, we also use a land use filtering approach so that we can basically consider both climate change and land use change in these scenarios. So if you look at the plots here, so this is the change in biodiversity in the future. And so if we go from top to bottom, what we see is the effect of climate change in 2 different scenarios. So that's the low emission scenario compatible with 2-degree warming. This one is the RCP 6.0, so it's a higher emission scenario. And here clearly you see that the impact, slides are running from themselves. So the impact of climate change is basically increasing when we are in a higher emission scenario. That makes sense. And what is interesting to compare also is when we compare side by side, so that's basically the impact of two different land use scenarios. Here it's a SSP1 scenario, so sustainability scenario of land use, and this one is a SSP4, so more intensive in terms of land use. And interestingly, we see that in the context of the first scenario, I'm sorry, it's a bit annoying that the slides are doing that. In the context of the SSP1 scenario, we see that it's in some regions, like in Africa, the land use change is actually able to even alleviate some of the impact of climate change, while in the less sustainable scenario SSP4, this is the opposite. We see actually bigger biodiversity loss due to land use change. So overall, this is showing that basically land use change is a key component in these future scenarios that needs to be taken into account. Not only, so the biodiversity change in the future will be not only determined by climate change, but also by this by land use choices, basically, which provides also a bit of a background or justification for looking at nature-based solutions from a land perspective, because these will be essential to preserve biodiversity while tackling the issue of climate change. So in this second example, I will talk through it a bit much more succinctly here, but it's just showing that we do also this kind of assessment of risk from also a smaller scale perspective, in this case in different Swiss cities. So that's the city of Bern, when we assess the risk arising or related to heat waves in cities at a relatively fine level. And we basically use a risk framework where we combine the hazard, so that's the temperature change, the exposure and the vulnerability, to derive then the risk in terms of this high temperature in cities. And then we complement this by doing tree scenarios, so urban tree scenario, where we do increase or reduce the amount of trees in the cities to see how the risk basically is modulated by that. So that's what we do at this much smaller scale, which gives me also a transition to the second part of the presentation in terms of, so what are the possible strategies that we can implement to address this risk. So here it was the example of trees in cities, but another example which we are looking at here, so to illustrate this design of nature-based approaches, is an example taken from Kenya, where we basically, so that's a very big project that is not only my group, but it's basically involving different units at the Wyss Academy and also external partners. For instance, Just Dig It, which is an NGO in Kenya. And what we do here is some grassland restoration using water burns. You see on this picture, the challenge is that we have this type of landscape in northern Kenya, where we have some part of the regions which is highly degraded, so the soils are really degraded. It's actually illustrating a bit the problem I was talking about in the first example on biodiversity, that land use and climate change both play an important role. And here it's something that is somehow, it's the same kind of a narrative, but at a much smaller scale, where we see that climate change, in particular the intensification of droughts, plus land use, in particular overgrazing, have led to this kind of landscape which are highly degraded. When it's raining, the precipitation doesn't infiltrate because the soil are bare and are very hard. So basically it's all going through a surface runoff. And here the experiment we try to restore this land in this conservancy is to dig these semicircular bunds, which are basically in the direction of the water flow. So when the water is flowing, the water is stopped by these bunds. And along or around these bunds, we plant species of local grasses, so that once the water is there, these grasses can sprout again. And we had these sites where we dug, or it's across 6 sites where there was more than 5,000 of this structure that were dug. And then you see that after the first rain event, it did work. So we had the grass coming back, although it was not there in the previous year. So it's really showing that it can work. At least the first steps is positive. And now we are actually going into monitoring what is happening there. So it's just to show the location within Kenya. So that's the Evasoniro Basin, the Laikipia County, and that's the location of the sites where these burns have been dug. And in addition, we are monitoring where you see the red dots. We are actually doing a monitoring of what is happening, and this is what is shown here. So we basically follow the soil moisture content in or outside the burns. The red curve is the control outside the burn. So if we don't do anything, and the other colors are different type of burns, with biochar, without, etc. Different treatments. What is very interesting is that we see that actually it works in the sense that if you look at the first, so in the shallow level of the soil at 10 centimeter depth, you see that after a rain event, so we see the rain here, we have an increase in soil moisture, and it's true also in the control. But as we go deeper into the soil, we see that the moisture, when we have the burns, is able to infiltrate deeper, whereas in the control, there is no moisture anymore. So that confirms the theory that by having these burns, we are able to actually to basically enhance infiltration, and supposedly we are able. That's what we want to test later. We are able to increase the recharge rate of the aquifer, which is a major part of the hydrological cycle in the region, because many springs are actually originated from groundwater. So basically, that's the first step, showing that the restoration, at least in the first weeks or months, has been successful. Of course, we are continuing to monitor that over many more months and years to see whether where this is going. And in parallel, we are also doing some modeling. There are no results yet, but I'm just showing you the framework. We will use the community land model to basically try to answer questions about the larger scale effect of this change. Does it affect the hydrology at a larger scale? Do we have changes in evapotranspiration? Does it affect also precipitation in the atmosphere? Does it increase the recharge of the aquifer, etc.? So combining this monitoring with the modeling, we hope to be able to answer this question of more generally the impact of this burn on the hydrological cycle. And yes, so that's what I wanted to say on this part of the presentation. Basically, also transitioning now to the third part, which is assessing the larger scale impacts of this type of approaches. So similar to what we want to do in Kenya, but in Kenya we are still in an early phase, basically designing the modeling experiments. But in Europe, I have an example here which shows that. So we have done simulations to basically ask similar questions. Of course, not in the context of an arid system, in the context of grassland, but in the context of Europe, it was more around restoration of forest. But basically now showing what can be the larger scale implications of this kind of scenario. So what we did here is that we looked at a restoration scenario. You see the map here is where we, in this scenario, we are adding trees, including biodiversity and food security safeguards. So we don't put trees everywhere, but only if this is not negatively influencing biodiversity and food security. And then based on this scenario, we derived a set of future scenarios where we combine climate modeling and statistical modeling to assess what could be the effect of this reforestation scenario and how would it combine basically with what we know about climate change over Europe. And looking at summer specifically, what we see here is first the effect of climate change in a middle of the road emission scenario. So that's a pattern we know is basically in the future. So that's precipitation change. We see that in the future we expect a reduction of precipitation in the southern part of Europe. So a drying trend. And here in the reforestation, so if we look at this scenario and we translate this into a change of precipitation using a statistical method, we see that actually we have an increase in summer still, an increase in precipitation, which is due to to the higher amount of forest and higher amount of evapotranspiration. When we combine these two effects, so if we combine climate change and reforestation, interestingly, we see that a lot of the initial impact of climate change is actually alleviated in this scenario due to the reforestation. So that's an interesting example where we basically can see here that some nature-based approaches can actually help to bring more resilience to climate change impacts in the future. And now to finish with a last example, going a bit more into a larger scale again, and also bringing mitigation into the picture, because so far I've mainly focused on the adaptation benefit, but now opening up to mitigation as well, and still looking at forest. This is a study that we have done some time ago with colleagues at ETH, where we see that so we basically try to derive the mitigation potential of forest, separating the effect of restoring versus conserving forest. And we use a metric which is in CO2 equivalent, which is not only considering carbon, but which also consider biogeophysical effects, so the effect of trees on albedo, evapotranspiration, etc. So it's a combined metric, which we can interpret as a mitigation potential, but it's not only CO2 basically. And the interesting result here is that we see first higher values in the tropics, so there is more mitigation potential in the tropics. That's not particularly surprising, but what is interesting is that we have much higher mitigation potential in the conservation case. So that's basically, that means the avoided emission if we would not convert these currently existing forest. That's the mitigation potential we have. It's much higher than what we gain if we actually restore these forests. So the message here, which is quite interesting, is that there is scientific evidence that protecting or conserving should be prioritized over restoring, basically. So basically, it wouldn't make too much sense to first deforest an area and then compensate this by reforesting somewhere else, because we see that there is much more to lose by losing the currently remaining ecosystem than we restore them. And so that brings me maybe to a last remark around this, which is that if we consider a bit the how now, because it's of course easy to say that we need to put effort in conserving ecosystems, but there is still the question of how do we do it? What are the tools available to do that? And specifically looking at carbon markets, which are booming at the moment, we see that there is a caveat there that these carbon markets, they show some success when it comes to restoring, but when it comes to conserving, basically forest or ecosystem, there are really big controversies and issues arising. So meaning that, in other words, this carbon market mechanism is not well aligned with this with basically this priority of protecting over restoring. So that's maybe a point of concern and also of an avenue for future research, I would say. So I will basically stop here and now conclude based on what I showed here. So in this example, I try to illustrate first that land use choices matter, of course, along with climate change, but it's clear that we see that they will play a role in the future in alleviating or sometimes exacerbating the trends that we see, such as the biodiversity trends. So because land use is so central, it means that nature-based approaches have, of course, a role to play in this future scenario. I would say they are certainly not sufficient, that's for sure, to tackle climate change, but they are necessary because these approaches have the potential to foster synergies, particularly between climate and biodiversity. So an example is the study I showed where precipitation in Europe is positively affected by the restoration of forest. And finally, a point which is a bit more specific about the how. So how do we implement these approaches? And there, I must say, I have much less experience myself, but I would say that there is something to think about, or food for thought, when it's come to basically the role of carbon markets and whether they are really aligned to the challenge of basically conserving as a priority this remaining ecosystem. And with this, I want to thank you, and I'm very happy to hear your questions.
Dr. Peter Bebi is a natural scientist studying the dynamics, management, and ecosystem services of mountain ecosystems. He is particularly focusing on mountain forests and tree-line ecosystems and on interactions between natural hazards and the other natural disturbances with mountain forests. He is, since 2021, head of the research center entitled Climate Change, Extremes, and Natural Hazard in Alpine Regions at the WSL in Davos. Peter, the floor is yours.
Thank you very much, Charmy. Welcome to this presentation. I'm glad to really compliment Edouard, what he said on the global scale, to say something about what does it mean in the Alps, does it mean when related to forest management, climate adaptation, and climate mitigated in mountain forests. So the content is that I would like to give a broad overview about the dynamics and then management in mountain forests in the Alps, say something about climate adaptation, climate mitigation, which of course is mixed, and give some conclusions later. The mountain forests in the Alps, they are strongly shaped by land use history. And you see that when you look at old pictures from landscapes, there was much less forest. So we had a forest increase by about more than 30% in the last century. So we had a forest exploitation over centuries. People used the wood to build houses, to burn the wood, and also, like in this picture, from a mining industry. This picture was, or the painting was taken in 1839, and afterwards you see the same view now. So it's full of forest here, and we had then a change actually in the middle of the 19th century. So we had floods, which were certainly one of the triggers to have a new forest law in 1876. We had more concern about sustainability and the end of clear cutting in Switzerland. So after about 1850, we had an increase in forest cover in the Alps. We see that also when you look at old pictures here. You see Davos around 1900 and Davos 120 years later. So when you look at the stands there, you see around 1900 there was a lot of grazing, particularly with goats. And then now we have here a 100-year-old stand, uniform, low biodiversity, low resilience, and actually no potential for increasing carbon because it's so dense. It's beginning of self-thinning, so it's a lot of mortality here. It's not there's not a lot of potential here to have more carbon in such forests, and we have a very high risks of disturbances like windthrow, snow breakage, bark beetle, fire in such stands. And this is actually what happened in the last decades. We had more natural disturbances in these forests. Quite a shock for the many people. Foresters in the Alps was the Vivian windthrow in 1990. You see here a picture of one of these windthrow above a village. So of course there was great concern about what's happening with natural hazards, avalanche, rockfall, landslide in such situations. The same view just 2 years later. So people have taken the wood out, have built avalanche barriers, and have reforested these forests, as it was usually have been done in such cases. It looked 1995, like we see it on the left, and 25 years later, we had the forest again. We had also the protective function again. So this is the situation, and the trend in the European context looks like this. We have increasing fire, we have increasing insect outbreak and wind throw. So this is partly because of the densification of the forests, of the forest expansion, and partly because of climate change, in particular with fire and bark beetle outbreaks, which are strongly linked to increasing temperature and drought. Would like to say something about the management of protective forests. So about 50% of the forests in Switzerland, they have a protective role against avalanches, rockfall, or landslides. So there is a yearly investment of about 100 million Swiss francs. And the idea is to manage these forests according to guidelines, which is actually also a nature-based solution. So we do it here as much as possible like the nature would do it. So we follow as much as possible the natural dynamics and invest the money, make management interventions where it seems necessary to have a sustainable protection function. In the last decades, we had a strong focus shift from afforestation, from increasing forest towards resilient increase. And in the last years, I would say, shift towards also to climate adaptation. So we bring in more light in the forest and we bring in more diversity in terms of species and structure. So what we do in the mountain forests, we make cable lines, bring light in the forest if necessary. If there is, for example, like here, only one tree species, spruce, which is susceptible to bark beetle outbreaks, try to plant other species which have a more future. There is a strong need for climate adaptation. When you look at the potential distribution area here for a beech, there is quite a lot of change, and we saw in the last years that some of these models, which seemed very surprising a couple of years ago, actually become true, because beech had a lot of problems on some sites. So we have we expect in the future a drastic shift of potential distribution areas, but we have also high uncertainties with these tree species. So a good idea is to increase tree species diversity. That's probably the most promising approach for climate adaptation, in particular in mountain forests, where we have just very few species, very few tree species. A question which often comes is it necessary to manage these forests? And what I would say here, it depends. And not every forest has to be managed for climate adaptation. Not every forest has to be managed for a sustainable fulfillment of protective function, and not every forest has to be managed for climate mitigation. So this is an example where it's a forest with no land use history almost, so almost no interventions here. There is a very high structural diversity. It seems to be quite in a balance. Also, the volume is very high, so it's 850 square meters per hectare and still increasing. So it's still a carbon sink, and actually in such type of forest, we have no need for active management. In contrast to, for example, this example which I have shown before with the very dense structure, which it would have been good to manage before, because before such a state is reached. Similar things, we have done a lot of research in the last years with post-disturbance stands. So stands where we have a disturbance, and in some cases we were lucky to have to make research on stands where no management has been done, like here in this bark beetle stand, Gantberg, after the Vivian wind throw. So people had just, the foresters had just not time to manage it, so they left all the trees here, and we could follow the post-disturbance development. What we see here, we see quite a high diversity after 20 years. Also, we saw that the protective function had a minimum after about 15 years, and now is increasing. So it was in this case, it would have been not necessary to manage it. It's not everywhere the case. We saw it on a variety of wind throw areas where no management have been done, that the species diversity has increased, in particular in the last years, and now increasingly there is also dead wood regeneration. So on the decomposing dead wood, trees, young trees are regenerating. So in summary here, we see that natural disturbances may not only seen as a catastrophe, but also seen as an opportunity for biodiversity and climate adaptation. Of course, there is a trade-off with climate mitigation, because the carbon, it's decomposing, so it's most of it is gone, and but the forest is regenerating. There are limits of passive management. So in some areas, it's just not possible. So where we have mobile dead wood, where this is a risk for people, like here, this is a new wind throw in my area, which is just very, very steep, and the wood is moving down to the railway, and it's just a risk for people. So the option is just to remove it and to secure it. Or where risks related to follow-up disturbances like bark beetles are too high, or where just a sustainable management of wood resources makes sense in an overall context. And sometimes we have no options for climate adaptation when we do not manage. So in this case, we had, this is from the Southern Tyrol, where we have a pine forests, and actually the pines, they get to their limits from the climate adaptation point of view. So people had to plant broadleaf trees, more adapted broadleaf trees, and fence them in, because the wildlife, because the browsing density or the browsing was so high. So here, some management was necessary because of these circumstances. So the potential for so I come to the climate mitigation topic a bit more. So we have a very variable potential for climate mitigation. As you see on the left, there are a lot of forests with a still high potential. So the carbon stocks in the picture on the left can still increase. We have a forest stand which looks quite sustainable. So there is a potential to have increased stocks here. On the right side, a similar picture which I have shown in the beginning, usually 100 years old stands, post-afforestation or post-land use agricultural land, which are now in a critical stage, and where the need for management before such a state is reached is quite high. When you look at tree line ecotones, this is often a question. So what happens with the tree line ecotones? The tree line is rising with climate change when management allows it. So when there is land use change there, and then the tree line is rising with temperature, because many tree lines in the Alps are temperature limited. Here an example of forest expansion on tree line. We see here trade-offs, because this is a very species-rich habitat. So if trees are encroaching here, it's a loss of biodiversity. On the other side, this is an avalanche release area, so we'll have less avalanches further down. So it's important to do the right thing at the right place. When you look at this site from a other view, you see there was active afforestation here, a lot of, so the trees have been planted. And this is maybe good in this case, in some of these cases, for the avalanche protection, but it's bad for the biodiversity, because these trees are now getting, they are growing together to a very dense stand, and the biodiversity is, of course, decreased a lot. So important to do the right thing at the right place. So what does it mean, the tree line shifts or the forest expansion for the climate feedback? And here we had done a study, and I'm lucky to show this picture because this was one of two papers which we published actually together with Edouard. So I'm glad to show that. Jonas Schwab, formerly a master's student here, did a study where he studied climate forcing in Switzerland by forest expansion. And he looked not only at the CO2 sequestration, but also at the albedo effect. And we see here Switzerland, and we compared the radial forcing by the cooling effect of CO2 sequestration if we have more forest, and the warming effect by a higher solar radiation absorbing, so smaller albedo of forest in snow-covered areas. And what we see here is in most of Switzerland, the CO2 sequestration effect is more important, not surprising in the lowlands, also in the Jura, the Tessin. But in some of the higher areas, which are snow-rich, the more continental areas, this albedo effect is actually stronger. So when we have more trees above tree line or with forest expansion in these areas, when you calculate only these two climate feedbacks together, so the CO2 sequestration and the albedo effect, then the albedo effect is stronger. So it's not everywhere a good idea to do climate mitigation projects in high elevations with planting of forests, especially if it's also not good for other ecosystem services, if it's also not beneficial for biodiversity. It's also what we have to consider that we have a potentially important contribution of wood as renewable energy, renewable resource. So I think it's very important to include that in the topic. So when we talk about conservation, it makes sense in many areas, but in some regions, it makes also sense to use some of these renewable resources instead of use the wood from foreign countries. Important is that we have regional follow-up wood processing and cascades of wood products. That's certainly important. And what we see when we did some studies to look at the different ecosystem services, the potential also for wood resources and potential for natural hazard protection. And we see that it's spatially very variable. So we have the potential for optimizing synergies between sustainable use of wood resources, biodiversity, and hazard protection. It's quite a challenging topic, and it's important that research and practitioners work closely together here. So with that, I come to my conclusions, which are, I have 3 conclusions listed here. First, the management of mountain forests is highly challenging because of legacies of past management, an increasing demand for ecosystem services, in particular the protective role of these forests, with the higher traffic in the Alps. It's getting more important also, this need for this ecosystem service. And we have increasingly challenges by climate change and by the need for climate adaptation. So it's increasing a topic in the mountain forest management. The increase of tree species and structural diversity is often a very promising approach for climate adaptation and the sustainable provision of ecosystem services. Conservation strategies, like Edouard also mentioned, they are sometimes a good idea, but not everywhere. So it needs to be done spatially at the right place. And the last conclusion, climate mitigation brings certainly trade-offs and synergies, depending on where we are. with the provision of biodiversity and various ecosystem services. So optimizing this potential needs synergistic collaboration between research and practitioners, decision makers on different levels. Thank you very much for your attention.